Okay, so let me just talk about how I got these, and then we'll go down and start doing our problems. So cosine of alpha, alpha is 1/4. Cosine of alpha is 1/4. So when I draw my picture, alpha is between -pi/2 and 0. So I know it's in the fourth quadrant. I drew this so that x is 1. I went off the unit circle. X is 1, r is 4. Now remember, you still could do the Pythagorean identities. Sine squared plus this cosine squared, 1/4 squared, has to equal 1, and solve for sine squared. But most of you, I think, felt like it was easier that you draw the picture. X over r is the cosine. So if you use Pythagorean theorem, 1 squared plus y squared equals 4 squared, and you solve for y, you should get y is either positive or negative radical 15, and it's going to be negative because it's in the fourth quadrant. So now from my picture, I can find the sine. Sine is y over r. Cosine they gave me, x over r. Tangent's y over x. Any of the things we need to find for alpha. For beta, when I look at beta, beta is between 0 and pi/2, so I know that's in the first quadrant. Sine is the y value over r. So again, I use Pythagorean theorem, 1 squared plus x squared equals 3 squared. I got x squared was 8, so the square root of 8 is 2 radical 2, and again, that's either plus or minus, but I know it's plus because it is in the first quadrant. So those are my angles, that information about the two angles I needed. So then when I go to the problems, first problem says, let's find the sine of alpha plus beta. So when you go to your formula sheet, sine of alpha plus beta, I wrote down right here. So I need to take the sine of alpha. So I go up to alpha. The sine of alpha is y over r. So it's going to be negative radical 15 over 4. Then it says the cosine of beta. So I come over to beta. Be careful you're on the right angle. Cosine of beta is going to be x over r. So it's going to be 2 radical 2 over 3. All right, then it says I go back to the cosine of alpha. They gave me the cosine of alpha, it's 1/4. And then the sine of beta, they gave me the sine of beta is 1/3. So now when I multiply these two, in the numerator I have to take 2 radical 2 times negative radical 15. You can multiply what's under the radicals. So you're going to get negative 2 radical 30 plus 1 all over. In both cases, you're going to get 12. So here you have negative 2 radical 30 over 12 plus 1 over 12 is negative 2 radical 30 plus 1 all over 12. All right, B, tangent of alpha over 2. Tangent of theta over 2, there's 3 different formulas. Doesn't matter which one I use. I'm dealing with alpha, so I guess it doesn't matter. I think I already in the front side used this one, so let me use the bottom one. I definitely would stay away from this one because you don't want to deal with the plus or minus. So let's say we deal with the bottom one. We're going to take the sine of alpha. I'll write this out so we have it. Sine of alpha over 1 plus cosine alpha. That's the formula I'm using. So when I go up to alpha, what is the sine of alpha? Sine is the y value over the r value. So it's negative radical 15 over 4 over 1 plus the cosine of alpha is 1/4. So I just took the sine of alpha over 1 plus the cosine of alpha. And then I just need to multiply by 4 over 4. Negative radical 15 over, down here I have to take 4 times 1, and then I have to take 4 times 1/4. So I end up getting negative radical 15 over 5. Okay. All right. And any of those formulas would work. You might get different answers, although I think most of them will give you the same answer or something pretty equivalent to it. Cosine of 2 beta. That's another one that I have actually 3 different formulas for, so it really doesn't matter which one I use. Since I'm dealing with beta, if I were to doing this on a test, I would look at this and say, well, they gave me sine of beta. So if I can use a formula that only deals with the sine of beta, I know I'm right, even if all of this is wrong down here. So if I were going to do the cosine of 2 beta, I would look at this and say, I want to work with the one that just talks about the sine of the angle. So I would use this one. Doesn't really matter, but that would be the safe bet to do. So I'm going to say this is going to equal 1 minus 2 sine of that angle, which in this case is beta. All right, 2 sine squared, sorry, of beta. All right, so we're going to plug that in. 1 minus 2, the sine was 1/3. So I'm going to take 1 minus 2 times 1/3 squared. Order of operations says I have to square first. I get 1/9. Negative 2 times 1/9 is negative 2/9. And if I have 1 and I take away 2/9, I'm left with 7/9. So that's what I ended up getting for that one. All right, and then the last one. Last one is cosecant of beta over 2. So when I go to my formulas, I'm looking at the half angles, and cosecant's a reciprocal of the sine. So the cosecant is just going to be the flip, the reciprocal of that. So when I go for my formula, I'm going to write this as cosecant of plus or minus square root of 2 over 1 minus the cosine of my angle. Now realize in your formula it's all thetas, but we're dealing with a beta, so you just say cosine of beta. So we can deal with the plus or minus. Let's do this one later. Let's first just deal with what's inside of here. So I need to plug in the cosine of beta, so it's plus or minus square root of 2 over 1 minus. If I go up to the cosine of beta, beta's up here, cosine is the x over the r, so it's 2 radical 2 over 3. And then all I need to do to simplify that is multiply by 3 over 3. So I get plus or minus square root of 6 over 3 minus, with this, remember I have to take 3 times 1, and then this one, the 3's drop out, 2 radical 2. So it's the square root, I better make sure you can tell that, it's the square root of that whole thing. And again, we said that we aren't going to make you rationalize that denominator at all. Okay, so now we just have to decide the plus or minus. So we have to go back up to beta. I want to know, is the cosecant of beta over 2 positive or negative? So when I go up to beta, beta was between 0 and pi over 2. So if I take half of beta, if I divide all these by 2, half of beta is still going to be between 0 and if I take pi over 2 and divide it by 2, I get pi over 4. And really, I don't even know if you'd have to think about that with this one. If it's in the first quadrant and I take half of it, I still should be in that first quadrant. But sometimes it's not that obvious. So to get it, you just divide everything by 2. So beta over 2 is between 0 and pi over 4. And so then I look at that and say, okay, so if I'm between 0 and pi over 4, is the cosecant, the reciprocal of the sine, going to be positive or negative? Well, it's going to be positive. In fact, everything in the first quadrant is positive. So that was my answer to that one. It is a positive. You don't have to put the plus sign there if you don't want to. Just make sure you distinguish if it's positive or negative. Okay, so that is number 5. And if you look, most of these, probably you'll get the same answers with these because these specifically tell you what you're looking for. Unlike the front, remember, some of these in the front, you would have gotten different answers for all of them, depending on if you used sum and difference or if you used half angle. And I would accept either of those. So on the front, you're going to get different kinds of answers. On the back, we all should have gotten the same answer for those. Just maybe sometimes a different way to get to them. Except for, I guess, maybe D. D, probably there might be some other possibilities, I guess, if you would have used, no, because that one's sine. I guess it's only going to get different possibilities if you can use one of these, or if you can use one of these differently, or if on the front you either use sum and difference or half angle. Okay, so look those over. Look over your other worksheets. You get to use all of those on your quiz or your homework learning check. You can use all of the 3 worksheets, and you can use this trig identities formula sheet. Those are the 4 things you can use for that homework learning check tomorrow. All right, there you go.